is Rowan Peterson, and I'm presenting today on comparing the results of long-term grazed and ungrazed plots on native plant-rich Valpie Ridge in Sonoma. This is my senior thesis from my undergrad at Berkeley. So first, a little background on the 10-year East Bay Regional Park District grazing study. So from 2002 to 2011, this was a collaboration between the district and the Range Lab at Berkeley. It established monitoring plots, both grazed and ungrazed, at 7 different parks in order to understand grassland structure and composition better and make site-specific recommendations about management. And data were collected as part of this project at Valpie Ridge in Sonoma from 2005 to 2011. And based on the original study, the management goals at Sonoma were to maintain the high native forb cover and diversity, and to reduce and prevent encroachment by invasive species of concern. So why is Valpie Ridge such an interesting site to study? For one thing, it has really unusually high native forb cover and diversity for a California annual grassland. And the existence of the longer term data set stretching back to 2005 for some plots and 2009 for other plots gave the opportunity to ask longer term questions about trends in plant community composition. So for my thesis, I did a resurvey in May of 2019, 8 years after the original study had ended, of 5 plots on Valpie Ridge. And 2 of them were ungrazed exclosures that had been in place since 2009, and 3 of the plots were grazed. My research questions were, how do grazed and ungrazed plots differ in cover and richness of grasses and forbs, native and exotic species, annual and perennial species, invasive weeds of concern, and litter and bare ground? I also wondered how grazed and ungrazed plots differed in vegetation height, and how species composition of ungrazed plots diverged from that of grazed plots over time, and how so and how much. So briefly going over methods, we used the same field methods for the resurvey as for the original study. We used point intercept sampling with 280 points per plot, as well as a time search afterward to capture more of the species richness of each plot. And I analyzed the data in R using linear and mixed effects models to test for differences in cover and richness in the different variables between grazed and ungrazed plots. I also compared mean and coefficient of variation of height between grazed and ungrazed, and performed cluster and indicator species analysis to look for trends in groups of plants over time. Now I'll go into the good stuff, an overview of my findings. So for this project, I used a p-value of less than 0.1 as a threshold for near significance. I did this for a couple of reasons. One is that I didn't want to arbitrarily ignore results that might have relevance for conservation or management. This was also the rationale for not using a correction factor for multiple hypothesis testing. Also, the small sample size, which was dictated by the nature of this study as a follow-up to an original study with a pre-existing design, that meant that it was much less likely that I would get any p-values of less than 0.05, so I decided to use 0.1 and just openly acknowledge that it was near significance, not conventionally statistically significant. So there were no near significant differences found in litter cover or bare ground cover, which is a little surprising given that those are typically higher in grazed areas. None in annual cover, native species cover, or exotic species cover. There are also no near significant differences in total species richness or native species richness between grazed and ungrazed plots. There was a near significant difference in exotic species richness, but the effect size was really small. Basically, on average, there was about one more species on each ungrazed plot than on each grazed plot. Now for forb cover, as you can see from the graph, after the first year of the study, forb cover was consistently higher in grazed plots, an average of 8.4 percentage points higher. And it's also interesting to see on the graph that the first 2 years of the study had notably higher forb cover for both grazed and ungrazed plots than 2011 and 2019 down here, which suggests that there was something going on in the background. So for grass cover, basically the opposite pattern was true. It was consistently higher in ungrazed plots by about 8.7 percentage points. And it showed the reverse pattern of being less prevalent in the first 2 years of the study and more prevalent in 2011 and 2019. And I looked at the trends in the most common grass species at Valpie Ridge. And for Avena barbata, that was consistently more common on grazed plots. Just a note, I didn't statistically test the grass cover. It was just kind of an exploratory thing. So I thought that was kind of interesting. It seemed like the removal of grazing allowed our Avena barbata cover to increase. The same thing was not true of Bromus hortiaceus. It starts out being pretty similar in terms of cover at grazed and ungrazed sites, and then later becomes a larger component of cover at the grazed sites than at the ungrazed sites. So it appears to be pretty tolerant of grazing relative to the other common exotic grass species. And here's my favorite of these three graphs, which is Bromus diandra cover. And as you can see, it starts off really low in both the grazed and ungrazed plots and seems to increase steadily over time when grazing is removed in the black dots up here. So it looks like in the absence of grazing, Bromus diandra seems to take over a little bit at this site. Will not take over, only gets to about 15% cover, but still it becomes a much more widespread species. And moving on to perennial cover, that was consistently higher on grazed plots, which I thought, and it turns out that this was primarily driven by native perennial forbs, mainly Viola pedunculata and Sidalcia melliflora. Here's a nice picture of a native perennial that we observed at one of the sites. And yeah, as you can see from this graph, native perennial forb cover was consistently higher on grazed sites. It made up to 15% cover in some years on some plots, which is really high. And I thought this finding was kind of cool because I haven't seen any published studies in the literature that have found higher native perennial forb cover at grazed sites in the California annual grassland. So that was a cool thing to find. And I separated out the Viola pedunculata cover since that was both the most widespread native species and because of its importance for conservation. Viola pedunculata, although it's a really common native grassland species, it's an important food plant for an endangered butterfly species, the Calliope silverspot. And as you can, and as this graph kind of suggests, it seems to be fairly tolerant of grazing. It's not clear whether grazing benefits or not, because I didn't really test for that. But it at least doesn't seem to be harmed by grazing, which is a good piece of information to know when it comes to the Calliope silverspot and Viola pedunculata. Now I'll show a little bit of the height analysis. So this is a plot of mean heights with coefficient of variation as the error bars. So as is not surprising, mean height was consistently higher in ungrazed plots. That makes sense because grazing removes biomass. But where it gets more interesting is looking at the coefficient of variation of heights in grazed and ungrazed plots and how that changes over time. And you can see at first they're pretty similar to each other, but over time, the coefficient of variation of height for grazed plots becomes higher than that for ungrazed plots, and is notably so at the end of the study, in the resurvey year in 2019, which is interesting because it suggests that the grazed sites have greater vertical heterogeneity in vegetation, which is helpful to native fauna, including grassland songbirds. And previous studies have found similar things. So it was cool to get a little additional data to support that. So my cluster analysis, an indicator species analysis, resulted in a proposed state and transition model for this site, where the transition between the two states is grazing removal. And within each state, there's a transition from, there's a phase shift from the earlier years of the study, where erodium, which is an exotic forb, is a more common species, to where Bromus hortiaceus for grazed sites and avena, or just avena for ungrazed sites, are the more common species. Yeah, and I thought that the phase shift might be caused by drought, because the major drought in California in the early 2010s roughly started around this time. I thought that was a plausible explanation. But anyway, this was just an idea that I came up with based on the data and on my cluster analysis. I didn't have time to get the full cluster analysis into this presentation. So a few conclusions. At Valpie Ridge, grazing appears to increase forb cover, especially native perennial forb cover, while reducing the cover of primarily exotic grasses. Grazing also seems to increase vertical heterogeneity of habitat, which can benefit native fauna. And Viola pedunculata, which is the most common native species at the site and a key food source for the endangered Calliope silverspot butterfly, appears to not be harmed by grazing here. So overall, grazing at Valpie Ridge seems like an effective conservation tool. And now for acknowledgements. Here's a picture of the field crew eating our lunch on the resurvey day, May of 2019. I want to thank Michelle Hammond, Peter Hopkinson, and Denise DeFries of the Park District for their botany expertise and for helping to make the 2019 resurvey happen. The Range Lab at Berkeley for allowing me to use data from the original study, and Dr. Felix Ratcliffe for his advice and mentoring throughout the research process. Thank you very much. I'd be happy to answer any questions. So let's see, there's a question. You think you might look at your results in the context of precipitation levels and any changes in grazing management? Yeah, that's a really good question. I did actually look at precipitation levels at the site over time, but I didn't have room for that particular figure in this presentation. But I'd be happy to send along the full results if you'd like.
Yeah.
Let's see.
Okay, thanks. And thanks, Rowan. I'll try to help you get through these and organize. So the next one said, do you have percent cover data for annual non-native forb cover between grazed and ungrazed plots?
I think I do. There weren't any significant differences found in that category, I don't think. But yeah, that is something that I tested.
Okay, and then the next question is, did you look at or see differences in species richness between grazed and ungrazed plots?
Yeah. So overall species richness was not significantly different between grazed and ungrazed plots, and neither was native species richness. Exotic species richness was slightly higher in ungrazed plots, but the effect size was pretty small. There was an average of about one more exotic species per ungrazed plot in any given year than per grazed plot.
And the next question is, was grazing cattle based? Was the grazing animals in the study mostly cattle?
Yes, it was cattle.
And then the next one says, hi, Rowan. Thank you for your wonderful presentation. Your findings in reference to Viola pedunculata are super intriguing. I'm curious if you happen to notice any differences in growth, form, flower abundance between ungrazed and grazed plots.
Ooh, that is a really good question and would make a great follow-up. I didn't look for that, but that would be really interesting to find out.
And then the other says, thank you. Do you know much about the grazing pressure at Valpie Ridge? Were there any changes during the study?
I didn't really have access to that information. So unfortunately, I don't know the answer to that one.
Okay. And I think we can look into that. We could potentially help you with that now. Okay. And the next question is a bit of a repeat, but I see it's from Denise DeFries, our former wildland vegetation manager. So Denise, happy to have you here. I didn't see you earlier, so thanks for attending. Okay, another one, just a feedback. Great job, Rowan. Really interesting results. Now, the next one is, will you be looking at what the soils are there, thin or serpentine, to guide where to use ongoing grazing to maintain the areas of greater native forbs?
That's a good question. So I did look at soil data that were taken during the original study in, I think maybe like, I can't remember what year it was off the top of my head. But yeah, I don't really know for that one. I would think that using ongoing grazing to maintain the area of greater native forbs, I would just like, this would be my guess, but I would think that a good approach would be to look at where there are already greater native forbs, which this study area had. So yeah.
Yeah, but that it's also a good follow-up. So thanks.
Yeah.
And so,
Yeah.
so the next one is from our Deputy General Manager, Dr. Ana Alvarez, and it says, "Thank you for your interest in East Bay public lands. You have the attention of the people who manage these lands and the elected officials who set policy for the preservation of our natural world. And the question is, what would be the #1 message that you can share with us? After knowing all that you studied, what is the most important thing that you'd like the East Bay Parks to do?"
Oh, wow. I guess just to continue monitoring what the effects of grazing are, particularly on native species at sites where grazing is a conservation practice. Yeah, I think that's really important.
And then the question earlier, I think Jim Hansen asked the question earlier about the soils. So I've been going through these quickly. I haven't been looking at the names all the way, but Jim, Peter's answering the question now, saying soils on Valpie Ridge are certainly thin, but he doesn't believe they're serpentine, at least where the plots are. So a little more context there. But something we should continue the conversation on. So good comments. Looks like we have one more, and it says, "Great talk, Rowan. Can you go into more detail about what happened after 2010 that seemed to affect species composition? It sounds like it was likely drought driving the change. Would you expect those trends to reverse in high rainfall years?"
Yeah. So after 2010, yeah, I agree that it was likely drought that was driving the overall change from more forb dominated to more grass dominated. After 2010, I'm not sure whether or not those trends would reverse in high rainfall years. It would kind of depend on how, I guess, how big of a change this is. I guess, like, if you're familiar with state and transition models, like, it would depend on whether the drought-driven shift was like more of a smaller phase shift or a bigger state shift. So yeah, that would be an area where future monitoring is important. But yeah, I think it's plausible that forbs could become more, could compose a larger proportion of the vegetation again, but I don't know for certain. It's a good question.
Well, great. Well, thanks, Rowan, and thanks everyone for the great questions.